In this example, we're asked what type of function and why. And we see a table of different ages and what percentage of that age group owns a smartphone. And so the first thing that we do is we look at the change, and we know to do this we do y2 minus y1. And I have typed those in, and I notice about them that they are not constant. And then we do the y ratios, and that's y2 divided by y1. And again, I have typed them in, and what I notice about them is that they are not constant. So the next thing is to create a graph, to look at what's going on in the graph, because observing that neither the ratios or the change are constant just rules out exactly linear and exactly exponential, but it doesn't tell me what the answer is. So I went to my calculator, I hit Stat and Edit, and you can see I entered the data. So the first list there is the list of the ages, and the second is the percentage. And so now I want to create a window. So it looks like my window, giving myself a little room. I think I'll go 10 to 20 for the X. And giving myself a little room, I think I'll go 0 to 100 on the percentages to see all of that. So we said 10 to 20 on our ages. And we said 0 to 100 on the percentages. And then I go into my y equals, clear out formula that I have there, make sure I have plot warm turned on, and hit graph, and I see the shape. So I see my first data point right on the the axis that's drawn there, because that's at 10, which is where I started my graph, and then it goes up pretty steep and kind of levels off. So I'm going to attempt to draw this in my PowerPoint. So we went ages 10 to 20, 0 to 100%. They started about here, came up pretty steep, and then they kind of leveled off, but a little up and down going on in there. So what type of function and why? Well, what I observe is that I have a concave down shape. And so because of that, the graph that is concave down that we've studied is logarithmic. And that produces a concave down shape. So again, because it's data and it wasn't exactly all lined up, this is going to be approximately. And we're not going to learn anything in the chart to look for being constant with approximately logarithmic. What I do notice is that it's changing a lot at the beginning by 17 and 16, and then less as we go on. So that would help me understand the concave down shape. So in our calculator, we're going to go to Stat, and we're going to go over to Calculate, and we need a logarithmic one, and the one that they have available to us is option number 9, where you see ln for the natural log. So I want to go down to option 9, and I want to run a logarithmic regression. So I hit enter here. I am going to store this so we can look at the fit. So in order to store it, I hit bars, over to y bars, enter for function, enter for y1, enter a couple more times to calculate this. And so this equation is rather complicated, a little different than we've seen with the others, but we see they give us a number to fill in for A, a number to fill in for B, and then we have the natural log of X as part of our formula. So on our PowerPoint, I find the equation, and so our equation is y is equal to negative 157.455 plus 88.12 natural log X. And so we can see how that fits. I did store that on my calculator, so you see that in the y equals with all of its decimals, and I'll hit graph. And I find that it doesn't fit overly well. So although it's concave down, it's just not perfect. I'm going to change my window a little bit to see a little bit further. So if I start my x back at 0, that might be helpful. And I'm going to go out to, let's say, 50. And take my percentage up here, even though it doesn't make sense to 200%. That would be like everybody owns 2 cell phones. But when I zoom out that far, I see the clear concave down shape of my curve. So the equation definitely is concave down. Zoomed out this far, it looks like a little bit better fit, but we can still see that the data is really clustered about the curve rather than exactly on the curve. So it gives us an estimate of the data, but literally just an estimate. It does not calculate the data exactly, but it does approximate it. So going back to what we were asked and what we would be looking for is when I see a concave down shape, I can approximate that with a logarithmic function. The logarithmic function in my calculator is going to be option number 9 on that list, and that is going to give me the natural log regression, which gives me this function that includes the natural logarithm in it and gives me a concave down shape.